Let's talk about coronaviruses. Coronaviruses are a whole family of viruses, and they cause all kinds of diseases in chickens, pigs, cows, and many other animals. They've also infected humans. There was the SARS coronavirus outbreak in 2002 and 2003, the MERS coronavirus from 2012 to 2014, and the newest coronavirus in 2019 and 2020 that's being called the coronavirus, or COVID-19, or even SARS-CoV-2 due to its similarity to the original SARS coronavirus from the early 2000s. But whether we're talking about human or animal coronaviruses, all members of the coronavirus family have a lot in common. So let's dig deeper into coronaviruses. What do they look like? How do they work? How do they cause illness? And what can we do about it? Let's start with what they look like. All coronaviruses are round, and they're about 125 nanometers wide. 125 nanometers is about 1,000 times smaller than the width of a human hair. Even though they're super small, we can use powerful microscopes to take pictures of them. From those pictures, we can tell that in addition to being round, coronaviruses have a spiral around their center and a bunch of little sticks coming off the outside. The center spiral is a combination of their genome, which is made of RNA, and a protein called N, which helps keep the RNA orderly. The sticks on the outside of coronaviruses are proteins called spikes. These spike proteins make it look a little like the virus is wearing a crown. Crown in Spanish is corona, hence the name coronavirus. There are also two other proteins called M and E, which are in the wall of the virus. So, now that we know what coronaviruses look like, how do they work? The first thing that a coronavirus must do is infect a cell. But it can't infect just any cell. It needs to find a cell with the right receptor. Much like the prince from Cinderella searching for the girl to fit the shoe, the coronavirus has to find a cell with the right receptor for the spikes to interact with. In humans, the cells lining the bronchial tubes in the lungs are the ones with the right receptor. Once the coronavirus finds the right cell with the right receptor, it enters the cell and starts to get comfortable. It's kind of like inviting a friend over for dinner, but they show up with their own table and chairs, and they start pulling out all of the ingredients for tacos. And before you know it, there's guacamole, meat, and tortillas everywhere. Coronaviruses are kind of like that. They bring everything they need with them, except instead of taco ingredients, it's the machinery needed to make more coronaviruses. The coronavirus starts using the RNA it brought with it to make all of the proteins needed to turn this whole cell into a coronavirus factory. It makes many proteins that work to read the RNA and make even more proteins. It also makes the structural proteins that we saw earlier when we learned what coronaviruses look like. It makes the N protein that organizes the RNA, the M and E proteins that are in the walls of the virus, and the spikes that are found outside. But at this point, the cell is just full of these virus proteins floating around. How do they come together to form new viruses? The answer is that they hijack the cell's post office. Yeah, cells have post offices. The post office of the cell is a place called the Golgi, and it works closely with the factories of the cell called the endoplasmic reticulum. The endoplasmic reticulum factories are responsible for making proteins that cells need to live. The factories then give the proteins to the Golgi post office to ship to different places in the cell. It's like a factory making chocolate bars, and then giving those bars to a shipping company to ship to candy stores everywhere. The coronaviruses send their proteins to the endoplasmic reticulum factory to blend in with all the other proteins there. Once the spike, N, M, and E proteins, along with a copy of the RNA genome, get there, the M and E proteins work together and start gathering all the components they need to make new viruses. These viruses are then packaged, just like any of the other proteins needed for the cell, and they're shipped out. The virus packages end up being shipped out to the cell surface to be dumped outside the cell, which is perfect for the virus because now that they're outside the cell, the new viruses can infect even more cells. So now we've talked about what coronaviruses look like and how they work. But how exactly do they make you sick? I mentioned earlier that human coronaviruses infect the cells that line the bronchial tubes inside the lungs. When those cells start getting infected, the immune system goes on high alert. That high alert means that the immune system causes inflammation in the lungs to stop the virus. If you've ever had an infected cut, then you know that inflammation means swelling, pain, and heat. Inflammation in the lungs isn't that different. The inflammation can make it harder and more painful to breathe. The body also starts to heat up and create a fever to help stop the virus by making it too warm for the virus to function. Maybe you're now asking yourself, what does this all mean for treatment? If we know so much about coronaviruses, why don't we have a vaccine or some other form of treatment? Well, the problem is mutation. Viruses are really good at changing. Imagine that you had to copy a book by hand thousands of times. You would definitely make some mistakes. Some of those mistakes would be harmless. Instead of Gary likes cats, you might write Gary enjoys cats. It doesn't change the meaning at all, so it doesn't really matter. But imagine if instead of Gary likes cats, you accidentally wrote Gary hates cats. Now, that sentence is completely different. It's a mistake that totally changed what the sentence means. And virus mutations are like that. When the virus is copying its genome to put into all of the new viruses being formed, it's going to make some mistakes. Some of those mistakes will be harmless, but some might change the receptor that the virus uses to enter cells. Maybe one version of coronavirus used to infect bats, but there was a mistake when it was being copied, and now it can infect humans. This ability to make mistakes means that any treatment or vaccine that we create can be sidestepped by the coronavirus. Maybe a vaccine could provide immunity to 90% of the COVID-19 that's out there right now. But there could still be 10% that just happens to not be affected by it. That might slow down the infection, but COVID-19 would come back, sometimes even stronger than before. So what do we do if the virus can change? Well, we find a part of the virus that is so essential that it can't change and still have the virus work like it did before. This might not work for a vaccine, but it could work for a treatment. Kind of like the antiretrovirals that are very effective for HIV-1 treatment. With the COVID-19 pandemic, we don't have treatments or vaccines yet. But scientists and doctors are working on them and using the information we already have on the virus and also getting new information. All that we can do is limit our contact with each other so we stop transmitting the virus and giving it the chance to mutate. So, don't go out if you're sick. Wash your hands, limit any non-essential travel, and stay home. But as you do all of these things, know that there are so many people out there working just to keep you safe. If you have any questions about coronaviruses, feel free to leave them in the comments. I also encourage you to subscribe for more content and updates from the world of biology. But that's it for me. I'll see you next time.